Okay, perfect, amazing. We are so back now. Okay. So we gotta continue with what we're doing. We've been learning a bunch of stuffs, or a bunch of stuff, because we need to be up to date with everything. Now I'm continuing because I got distracted with work, cooking, sleeping, etc. Right? So now I'm catching up. I'm catching up now. And I'm going to use this cloud AI thing in order to improve my learning process, in order to boost my learning process. So let's go. We don't have enough time, so we have time, but it's not that enough. I mean, it is enough, but it's not forever. Let's give it 10 minutes to reveal a little bit of something, whatever. Let's see where was I on AWS? Where I was, let's see, pytorch, AWS. So we've been looking into S3. We've been talking about directory buckets. That's right. That's correct. Directory buckets. But I think we were done. We were done with that. We've been looking into S3 tables and table buckets, which is a way to store data information on S3, but it's actually data, plain data text that can be queried later with other systems. The way how data is being stored is using SQL, compatible with Apache Iceberg. So that's great. It has a cost because the tables have a maintenance. And well, that was pretty much it. Can be integrated with CloudTrail. It has identity-based authentication, SCP policies. It's not public yet. It's a brand new service. Cool. Then we reviewed about permissions. So let's go with it. So what about it? Access control? How we control the access to the S3 buckets and the objects. What mechanisms we have to do this? So what we have is a bunch of stuff going from IAM, permissions and access points, S3 access grants, ACLs, and just blocking public access. Checking ownership, controlling object ownership, which is something more like evaluation or auditing the S3 buckets. Let's start with IAM. And I remember we had a bunch of notes and like a review or a specification of what IAM is for, what does it have, how it works. I remember we had that and I wanted to skip it. So what IAM does here, authentication with identities. I think I got that here, or not? No, I don't have it. Okay. So it is basically policies that can be applied to users, to groups, to roles. And we need, well, the policy basically have this effect, whether we want to allow or deny. But other than that, and a common one is the version, which is the date. And the date usually is 2017 02 1002. I don't remember. Yeah. Other than the version, we have a bunch of statements, and each statement has each statement has the effect. It has the set of permissions we want to allow, and we need to specify the namespace of the resources and the property and the permission, specifically the permissions we want to apply. And then we also have the resources where we want to apply those permissions. Can be a list of resources, we can have variables, wildcards, etc. If we are creating a shared result, we don't need what? The actions. We don't need the actions. We just need the resources and the principal. And under the principal, we can have OIDC, we can have services, and that's it. I never saw actions, meaning what the subject can do. Yeah, for the service roles, I never saw that. Okay. So those policies can be applied to users, groups, and roles. Buckets can have their own bucket policies as well, not related to AAM. So we will see that later. So let's move on. How much time left? Oh wait, are we counting or not? Okay, we're about to finish, and I haven't even started yet. SCP. Okay, let's go. Let's move on. Okay, AAM. We have identity-based policies, resource-based policies, policy actions, policy resources, conditions in the policy, ACL. So it's basically all we've been talking about AAM policies. So let's describe a little bit how a policy is. Policy. A policy has a version. It has a bunch of statements. The statements. And these statements have the effect, action, resource, or can be plural as well. Actions, resources. So we can have here variables and conditions. This is not S3 really. S3. This is more IAM. So I need to see it all the time. I don't want. I need to know what time is it. Identity base for S3, resource policies within S3, principal for bucket policies. The principal can be a service or can be an AWS account. So this is interesting to know. But this is a service resource-based within Amazon S3. Resource-based policies are JSON documents that you attach to resource. Yeah, I am role trust policies. See, to enable a cross account access, you can specify an entire account or AAM entities. So you can basically let EC2 to have access to S3 or an entire AWS account to have access to a bucket S3 from another account. So that's a particular thing. Let's say AAM role, and this is principles, which can contain a service, can contain OIDC, I remember. It can contain an entire AWS account or a particular user under that particular AWS account, or all users. Or what? Is this public? We can use principal and wildcard, so that's anonymous. That's interesting to know. So this is purely IAM. We are learning IAM. We're not learning actually S3. So time's up. Time's up, bros. Service. So in service we can have whatever. EC2, CloudFront. This can be an AWS account, can be user, can be wildcard, which is anonymous, etc., etc., etc. Policy actions. So what actions we can apply? Like list objects, list buckets, put an object inside the bucket, delete something. So again, this is purely IAM. This is purely IAM. Access point operations. What does it mean? ARN access point. Okay, interesting to know. Resources can be S3 ARN. Access points, S3 access points. Then we have lambdas access points. Batch job operations. Oh, yeah, that's part of S3 as well. Lambdas, batch jobs. So we saw that before. We need permissions in order to execute the batch jobs. Wildcard characters and resource ARNs. Yes, that wildcard means everything under a specific thing. So we can apply conditions and policies, which is an optional block, where, for example, we can pick up all the buckets that have the standard infrequent access storage class. Oh, I'm sorry. This is particular for... Oh, interesting. We have here a statement that have SID, which is the statement ID effect, and we have principal, which is an AWS account and a particular user from AWS account. The action he's allowed to do is to put objects inside the bucket. The resource he can do that is a particular ARN bucket and a wildcard, meaning he can override objects, but only to those objects that have the storage class as standard infrequent access. Nice. So that's the full picture. That is the full picture. Note. A policy can have it all. I didn't know this. It can have the statement ID, the effect, principle. It can have the action. It can have the resource. It can have the condition. That's it. Now it's talking about ACLs, but there is not that much that it's just a single paragraph. ACLs are similar to resource-based policies, although they do not use JSON policy document format. Majority of modern use cases in Amazon S3 no longer require the use of ACLs. What is ABAC? Attribute-based access control. Okay, this is a long, we are almost there. I need to stop it there. So let's create a paragraph here, which is ACLs, access, attribute-based control access control. So let's stop there. And I really wanted to see some examples with Terraform. Come on. Okay, let's just do something here. I read access to documentation. Give me Terraform example so I can test myself on EC2 creation, EC2 spot dedicated hosts and instances, and what else? EC2 spot dedicated host instance, an instance, dedicated host, dedicated instances. What else? Placement groups. Serve instances. Storage, networking, monitoring with CloudWatch, S3 and AM access. No. S3 packet access via AM. SSM for remote SSH access. What else? User data. Autoscaling group. ALB. Launch templates. Use cases for instance types. And best practices. So go, show me examples. B. Okay. So what's next? What is next? Let's go with software development. Need to review some. Let's go with pytorch. Let's go with pytorch. All right, let's start the ticking of the clock. Come on, what's going on? Go. Do we have cloud? Oh, we have cloud. Amazing. Retry. Retry. Retry logging in again. Come on, time is going on. Retry. Not able to log in into my cloud account using my tablets. Okay, that's a bummer. That is a bummer. So what is going on here? Why there is no progress? Why we have no progress? Why there is no progress? Okay. So we're here. What we talking last time? PyTorch. So what was the workflow? Load the data using data sets, using data loaders, preparing the tensors. Then we create a model using the NN, the neural network model. We define the GPU usage. We optimize the model parameters by what? Where do we use the optimizer in the loss function? Okay, I guess it's here. We optimize the model parameters. Then we run some cycles, meaning we train the model and test the model. Finally, we save the model and we can load it again and start doing some tests. And we went right into tensors. Tensor is a data structure in PyTorch compatible with the NumPy multidimensional arrays. Tensors can fill up the data structures with some predefined data like zeros, ones, random numbers. We can do some math operations with tensors like concat, matmul, do in place operations for each number, for each field. We can load a NumPy n-dimensional array into a tensor, or we can do the opposite. We can convert a tensor object into a NumPy object. A tensor have a shape, a data type, and a device where it's going to be processed. So that's pretty much it. So where we are now, learn tutorials. No, I don't think it was tutorials. Tensors, yeah, it was tutorials. So we are done basically with the tensor tutorial. Next, data sets and data loaders. So what we got here. So how to use data sets and data loaders. That is what it's all about. That is doing it. Okay, I've got some easy-to examples to test myself. Oh, I don't want to use modules, not yet. Yes, amazing, amazing. Give me more real cases and examples, bro. You nailing it. Thanks, brother. projects. Now I need to learn something about pytorch. No? Okay, let's create a project. This has to be, yeah, machine learning, data science, etc., etc., etc. I'm learning about, data science. This project will give me code examples for me to practice and keep learning. Create project. Okay, let's go. Let's finish this up. We are late. Tensors. Tensors, we're done with tensors. Now let's go with data sets and data loaders. Data sets, data loaders. So code processing for data can be messy. For data samples can get messy and hard to maintain. We ideally want our data set code to be decoupled from our model training code for better reliability and modularity. Okay, so data processing has to be separated from the main objective, for the main training or the model creation. Okay, that's clear. We have two primitives, data loader and data set, which are pytorch, torch utilities. To preload and preprocess, dataset stores the samples and labels dataset. Data loader wraps an iterable around the dataset to enable easy access to the samples. Okay, datasets to preload, data loader to wrap the dataset objects with nice labels. Okay, here, how to use data sets and data loads to load the fashion MNIST dataset from Torch Vision. Okay, it's a database that has images, grayscale 28x28. Root is the path where the train data and test data is stored. Train specifies training or data or test data set. Test data set. Download equals true. Downloads the data from the internet if it's not available at root. Transform and target transform specify the feature and label transformation. And label transformation. So particularly the datasets have a root, a place, a train flag. The train flag says if we are training or we are just loading the data. Yeah, if we are training or just if the data is the training data or the test data. Okay, we have two type of data. We got two types of data. Train data, test data. That's what we have. This is done. Number one is gonna be data set. Number two will be data loader. These are pytorch utils. So data set just preloads the data. We have to specify if it is training data or testing data. We have to specify we want to download or not. We have to specify where is the data and if we want to download it or not, and what the transformer is going to be. Okay, thumbs up. Iterating and visualizing the visualizing the data set. We can index datasets manually, like training data and the index. We use matploit to visualize some samples in our training data. Matploit. We have a 3x3 matrix. We are iterating each of them in a for loop. We are picking up the ID and we are picking a random item from the torch object. Why we have torch here? So we're basically picking up the image and the label as the training data. Figure, plot title, plot axis, plot image show, which is the matploit, the matploit library. Matplot library. We can create a custom data set. A custom dataset class must implement 3 functions: init, len, and getItem. In this case, the images are stored in a particular imgdir directory, and the labels are in a separated scp file, the annotations file. So it's important to have the object and the label separated. I mean, both of them have to exist. Dataset, custom image dataset. So we are defining the init function where we specify where the annotations file is, the directory, the transform, target transform, the len, and the get item, where we have to manage indexes, the IDX. The init function is run once when we instantiate the object, the dataset object. Yeah, that makes sense. The len function returns the number of samples in the dataset. The get item loads and returns a sample from the dataset given the index ID. Okay, so we can create custom dataset classes. We can create them. Three functions. The init, the len, and the get item. So what else we have? Preparing your data for training with data loaders. Preparing your data for training with data loaders. While training a model, we typically want to pass samples in mini batches, reshuffle the data at every epoch to reduce the model overfitting, and use Python's multiprocessing to speed up data retrieval. Data loader is an iterable that abstracts this complexity for us in an easy API. Data loader, and we pass the data, the training data. Another one is going to be the test data, the batch size, and the shuffle, which is true for both of them, and mini batches. So that's going basically in parallel. What reshuffle means. Okay, it can do that. It iterate through the data loader. We have loaded the data set into the data loader and can iterate through the data sets as needed. Each iteration below returns a batch of train features and train labels, containing a 64 batch size, features, and labels respectively. Because we specified shuffle equals true, we iterate over all batches the data is shuffled. For finer grain control over the data loading orders, take a look at samplers. I didn't get. I think we need to have some examples, but that's all. That's all the documentation. Okay, first we need to load the data, preload the data in dataset object, and then we can use the data loader to iterate. And we have training data and test data. That's it. Let's go with cloud. So I read about tensors and datasets and data loaders on pytorch based on its documentation. Give me some code example so I can test and verify myself, train myself on those topics. Amaze me, Cloud AI. So what's next? Let's check. Oh, what? No, my connection is bad. I don't think so. You don't want to work for me today, huh? You don't want to work for me. What a bad guy. Come on, man. Work. Work, work, work. Okay, we're seeing something. Okay, this will take some time. Let's open again Cloud. Let's open up Ethereum documentation. What we can see there. Learn basics, advance. What is Ethereum? What is an Ether? Wallets. So let's see. Use build participate research. The foundation of let's check this out again. I don't want to. Okay. I need a new watch. This watch doesn't work. It sucks. Okay, let's go. Summary, let's start. Free and global Ethereum. What can Ethereum do? Banking for everyone, an open internet, a peer-to-peer network, censorship resistant, commerce guarantees. Customers have a secure built-in guarantee that funds will only change hands if you provide what was agreed. Likewise, developers can have certainty that the rules won't change on them. That's amazing. That's so people can trust Ethereum. Everyone. Let's start. Let's go. So what? Is that it? But how can I create something? How can I test myself? Learn, overview, advanced. What is Ethereum? Current price in USD, $1,000. Ooh. Get Ethereum. I don't want to get it yet. So I need technical documentation. Ethereum wallets, smart contracts, how you create smart contracts. Smart contracts, does it work with Solidity or what? Cryptographically secure process enable transactions, trust in conventional contracts, digital vending machine example. A simple metaphor for the smart contract is a vending machine, which works somewhat similarly to a smart contract. Specific inputs, warranty, predetermined outputs. You select a product, the vending machine displays the price, you pay the price, the vending machine verifies that you paid the right amount, the vending machine gives you your item. Okay, it's not what I expected. Gas fees, blockchain bridges. It evolved from L1 to L2, run on node, become fully sovereign with helping secure the network. How to run a node? You need software, you need hardware. Ethereum is designed to run a node on average consumer-grade computers. You can use any personal computer, but most users opt to run their node on dedicated hardware to eliminate the performance impact on their machine and minimize the node downtime. While online, running an Ethereum node might sound complicated at first, but it's merely the act of continuously running client software on a computer while connected to the internet. While offline, your node will simply be inactive until it gets back online and catches up with the latest changes. Or it can automatically catch up. Okay, but I need more technical documentation. Documentation. Get started. Newcomers. Okay, let's see. Let's see here. Ethereum developer resources. How you like to get started? Learn Ethereum development through tutorials. Start experimenting. Set up local environment. This all seems to be the same. Play with code. Learn by coding. So we have some boxes. A place to experiment. We got tenderly. Okay, let's take a note. Talking about here on Ethereum. Tools. Tenderly. We got the decentralized app world. We got Remix. I read about this before. Atlas, Chain IDE, Zeplit. Zeplit seems good. Cool. And it's using Solidity and Web3. Okay, cool. So they are all using Solidity, Viper, Solidity Web3. Web3. Remix is not using Web3. It's not a complete framework. So we'll take a look on Tenderly. Seems to be popular. Okay, cool. Set up your local environment, learn Ethereum step by step, build tutorials, and we got a bunch of tags. I don't know where to start. So let's go with learn Ethereum development. Cool. So what's the link here? Developers, documentations, foundational topics. This seems to be great. We can start over here. This documentation is designed to help build with Ethereum. It covers Ethereum as a concept. Explains the Ethereum tech stack, okay, and documents advanced topics for complex applications and use cases. Development modules. This is your first attempt at Ethereum development. We recommend to start at the beginning and working your way through like a book. No thanks. But how to make money? I need to be my millionaire. I guess I need to keep reading. What is a blockchain? Boring. What is a blockchain? It's a public database, yeah. Updated and shared across many computers in a network. Block refers to data as data, blah blah blah. Blocks. If you've sent it to someone else, the transaction needs to be added to a block to be successful. Chain refers to the fact that each block cryptographically references its parent. In other words, blocks get chained together. The data in a block cannot change without changing all the subsequent blocks, which will require the consensus of the entire network. I'm sorry, Claudia, you were working a lot. What you can show me about PyTorch now? Nothing. Data loaders. You got a lot of things going on here. Matplotlib, tensor examples. Okay, we can start doing tensor examples, operations, matmul, shape. We can initialize the data. Amazing. We can play with the data types. We can play with NumPy, tensor operations like adding, minus, blah, 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 blah. Operations, reshaping tensors, adding, removing dimensions, concatenating, indexing and slicing, moving tensors to GPU, gradients. Now, custom datasets, image datasets, a text dataset for NLP. Okay, that's good, but I need some data to test to prove that it works. Where can I get the data or how to create the data? Okay, we'll take on that later. Okay, time's up. Intro to Ethereum, intro to Ether, intro to the app. So pretty much introduction, foundational topics. So pretty much concepts. Ethereum stack, development networks, client APIs, IDEs, advanced, bridges, standard, oracles, scaling, data availability, network layer, data structures. I see. So no solidity at all. So what about solidity? Solidity documentation. Why it's a separated thing? What does it mean? Why it is separated? Solidity is an object-oriented high-level language for implementing smart contracts. Smart contracts are programs that govern the behavior of accounts within the Ethereum state. within smart contracts are programs that govern the behavior accounts within the Ethereum state. Ethereum. Solidity is a curly bracket language designed to target the EVM, Ethereum Virtual Machine. It's influenced by C++, Python, and JavaScript. It's statically typed, supports inheritance, libraries, and complex user-defined types. So is there any other language that can be used to create smart contracts? Alternative Solidity is for smart contracts, Ethereum. So what are the alternative? Even though Solidity is for writing Ethereum smart contracts, there are other languages like Viper and Move. Viper is considered more secure than Solidity for several reasons. Firstly, and secondly, it intentionally has a simpler and more restricted syntax and feature set, reducing the risk of complex error-prone code. So Viper, smart, Ethereum. Let's check this one. Viper documentation. Viper is a contract-oriented Pythonic programming language that targets the Ethereum virtual machine. So this is just for the Ethereum virtual machine. It prioritizes user safety, encourages clear coding practices via language design, and efficient execution. In other words, Viper code is safe, clear, and efficient. Principles and goals: security, language simplicity, auditability, features, bonds and overflow checking, support for signed integers and decimal fixed points, strong typing, clean and understandable compiler code, support for pure functions, are not allowed to change the state. Modifiers, class inheritance, inline assembly, function overloading, operator overloading, recursive calling, infinite length loops. Okay, it's better than Solidity, Viper. Okay, let's language. Solidity, no. Viper, yes. So it starts talking about a bunch of things here. What is a blockchain? What is a block? What is a chain? Every computer in a network, upon each new block, blah, blah, blah. The nodes make sure they interact. The blockchain has the same data. Ethereum uses proof of stake based consensus mechanism. Anyone who wants to add new blocks to the chain must stake Ethereum. It's the native currency in Ethereum as collateral and run validator software. These validators can then be randomly selected to propose blocks that other validators checks and add the blockchain. There is a system for rewards and penalties that strongly incentivize participants to be honest and available online as much as possible. Interesting. If you would like to see how blockchain data is hashed and subsequently append to the history of block references, be sure to check out this demo. What is Ethereum? Nice. Proof of stake based. Proof of stake. So what exactly stake is? Proof of stake. Via Ethereum, you have to buy it. Okay, let's see. Cryptos. I don't have any cryptos. Okay, create projects. I want to see code. Learning on Ethereum. Show me some code examples so I can test myself my knowledge. What about for coding? That's it. Extend it. Yes. So tell me something. Teach me something. In the meantime, okay, Viper, how is this thing? Yeah, it's pretty, it is Python. It has some weird definitions. What is this language? It's a mix of JavaScript and Python, it seems to me. Event, transfer, approval, state variables, balance, allowance, contract initialization, transfer of tokens, balance management, transfer from, we need to check balance, external, approve the transaction, ERC20 token with minting and burning. So this is another example. Minting and burning. Owner only minted. Transfer from approve. Mint function. Burn function. We can add minter. So there are functions that are available for the owner and others that can be available for everyone. Some of them are modifiable. Some of them are just read-only functions. Well, what's this example? Wait, what? This is another implementation for NFT. ERC721 NFTs. Okay, we got a bunch of examples. Cool. Nice. Nice. Nice, 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 nice. Django React. Let's go with Django and React. What we got here? Models. That was the last thing I've been reading. Okay. Django documentation and models. Give me code examples I can test myself. It has to include project creation, model creations, migrations. Data population, model relationships, testing, shell, interactive. What else? Group of models, complex field, complex model, queries with filters, excludes, lookups, go object, etc. etc. Okay. That's what I really I think I know what are all the properties of a model. Django model has a bunch of things: CRUDs, filters, excludes, get, all, updates, deletes. We can populate into database. We can run aggregations, annotations, distinct. We got relationships. We got a shell where we can test the model creations. We can run migrations. We can have custom migrations. We can use the shell and the testing features. The test case object. Okay, we have a bunch of things. Yeah, let's go with this a little bit, then let's review reactjs. For now, I will just take a look into the IA generated code because I have nothing else here. So this is the models chapter, how to retrieve objects using the get method. Retrieve an object, do the filtering, set of objects, excluding, lookups, order by, foreign keys, querying across relationships. You know how to do that. Many-to-many queries, yes. Update, delete. That's it. Now we have URL mapping, views, and templates. This chapter introduced to concepts, Django, views, templates, and URL mapping. You will start by exploring the two main types of Django: function-based views, class-based views. Okay. URL mapping, which belongs to views. And views can be function-based and class-based. And in the middle, we have templates to show up data with variables. Okay. So next, let's take a look at this, which is going to be URL view. Let's say views. Yeah, that's it. Views. And we will see here URL mapping. We see here templates. Yeah, function-based, class-based. So that's it. I need to read the code. I need to go. Oops. Are you done? Yes, you're done. Let's copy this. Let's go to stack edit. No, I'm sorry. Stack edit. And let's review the code. Oh, we already got something here, which is nice. So let's review a little bit. So we create a project, we create the apps, we modify the main settings by model creation is one of the first things I need to do. So let's take a note here because it's gonna be models laboratories. Model creation relationships. We have to heavily use fields because there is really a lot of fields: data fields, text fields, data time fields. We have to use the meta class to define to override which column is going to be the main one to order the data. verbose name plural. I don't know what that is. So we have to define a bunch of models to be created, and then we specify the relationships: foreign key, many to many, one to one. We can have custom functions. Okay. Then once we have the models, we migrate. We have to exercise the migration, which is going to be purely CLI. We don't need to do nothing crazy about it. We can create custom migrations, but I'm not doing that yet. Shell for testing. Okay, in the shell, we can test. So we can do crawl operations. And we will start creating objects. Relationships. And we will do some gets. We will do filtering, delete, save, or update. Then we will do more querying and filtering in a chain. We can chain these operations. Exclude queue. And we can use the queue object for complex and Boolean operations. The like queries or lookups. Complex aggregations, yeah, it's gonna be less. Model operations, advanced models. Yeah, we got advanced stuff here. Signals. It's getting crazy. It is getting crazy. Unbelievable crazy. So let's copy this. And let's see what is it about. Hope it's more simpler. Comprehensive tutorial. Yes. So that's pretty much it. Model creation, pretty much the same as the previous example. Pretty much the same. Slightly different, but pretty much the same. Oh, we have data population now. We need to create a command to populate the data. We are clearing the data out. This is really risky, but it's doing it. Creates, pre-populates some stuff. Wow. And then we execute the population option. And then we go with the Python shell. And we do it manually. Yeah, the same as the previous one. We create the objects one by one. And then we take care of the relationships. Well, it's already done. So we talk a little bit, or we discuss about relationships. For one to many foreign key, many to many, one to one, and then we start with the CRUD operations. And the red, we get objects, we get one single object, we update, we delete, and we start with the complex. Filtering, conditions, exclude, lookups, Boolean queries, aggregation and annotation, joins and relationships. Yeah, this is model relationships, subqueries and complex filters, order by. Basic interactive examples. I don't know what that is. Average concepts. Much seems to be more complex. Testing Django model. So the test case um, class asserts. I can't memorize all of this. I will need to test. Admin interface. This is really useful. Thank you. Admin interface. I need a place where I can log in and see how my data is looking like. React.js documentation. Let's go with this one now. React documentation. So I've been learning about React components, the JSX, use a state to store data temporarily, the CSS class names, events. So let's go. Welcome, conditional rendering. We did a tic-tac-toe tutorial. Well, I read about this. It was cool because I learned some best practices. And this is a line-by-line explanation. Taking in React, mockups, components, breaking the UI into component hierarchy. Build a static version in React. Find the minimal but complete representation of UI state. Identify where your state should live. Every component that renders something based on the state. Find the closest common parent component. Decide where the state should live. Oh, interesting. Add inverse data flow. Okay, I don't get this. Installation. So yeah, I understand this. Installation. React has designed from their start for gradual adoption. You can use as little or as much React as you need. Whether you want to get a taste of React, add some interactivity to an HTML page or start a complex React-powered app. This section will help you get started. Okay, we have a function, we have the function is the regular component, and we have a main function with the export default where we call the function, which is the component, and we pass a parameter that's going to be rendered in the component function. So how to do it? Creating a React app. Next.js app router. Full stack frameworks do not require a server. All the frameworks on this page support client-side rendering, single-page application, and static site generation. Also, we have server-side rendering, but this one is client-side rendering. Oh. Next.js App Router is a React framework that takes full advantage of React's architectures to enable full-stack React applications. Full-stack React apps. What does that mean? Next.js is maintained by Vercel. You can deploy a Next.js app to any Node.js or serverless hosting. Okay, so hosting Node.js or serverless compatible hosting. So what is this router? What is this? React router is the most popular routing library for React and can be paired with bytes to create a full stack React framework. So what is this byte and what is this React router version 7 Next.js app router? Both are routers. So what's the difference? What is the difference? React router is maintained by Shopify Expo for native apps. Expo is a React framework that lets you create universal Android, iOS, and web apps with truly native UIs. Nice. So there's a bunch of frameworks that can be used to create React apps. Start from scratch. If your app has constraints not well served by existing frameworks, you prefer to build your own framework. Ooh. Start from scratch. No. Well, you are using Byte anyway. The first step is to install a build tool like Byte, Parcel, or RS Build. These build tools provide features to package and run source codes, provide a development server, local development, and build command to deploy your app to production server. So Byte seems to be the preference here. Okay, we have an example with Byte, with Parcel, RS Build. No. Data fetching, code splitting, application performance, and more. Add React to an existing project. So are we sure we want to use this? Is this the right path to learn reactjs? Using TypeScript, blah, blah. React developer tools. Developer tools, React compiler. So what's next? That's it. I think it's missing a lot. Describing the UI. Your first component. Okay, I think this is the place. I think this is the place. Adding interactivity, managing a state, escape hatches. Yeah, I guess this is the thing. Your first component. Components, UI building blocks. Okay, let's go with Cloud AI. We have Django and React. Show me code examples on most common reactjs components in order to keep learning. Give me real case scenarios on React components. Okay, your first component. Components are one of the core concepts of React. UI building blocks. It has to be one root tag and have everything inside. Yes, I know. Defining a component. A React component is a JavaScript function that you can sprinkle with markup. We know this. Exports the component. Export default prefix is a standard JavaScript syntax, not specific to React. It lets you mark the main function in a file so that you can later import it from other files. Export default, that's interesting to know. Export default makes the function available in other files. Time's up. Then we define the function name, and we start writing HTML code. It has to be a return using the component. So how we can use it? If we have everything in one single file, so there is no need to use the export default, because that component is going to be used in that file. If we need the function to be available in other libraries, we need to use the export default prefix. Amazing, clear, cool. Nesting and organizing components. So this is gonna be great. Components can render other components, but you must never nest their definitions. Never define a component inside another component. Okay, that's a good practice. Okay, pitfall, that's a pitfall. Don't do this. Do not define a component inside another one. Great, amazing. Recap. So you learn a lot. Let's recap. React lets you create components, reusable UI elements. Every piece of UI is a component. React components are regular JavaScript functions, except their names always begin with a capital letter. They return JSX markup. Clear. Importing and exporting components. It's amazing. I understood. Yes. Are you done? Yes. Then show me the code. Okay, you got me an example here, and I want to see the example. So we'll open up Stack.io, and I will remove all of this, and I will paste this, and I will write your code. Paste. So let's see the examples. It is a lot. button component with loading state. We gotta use state. But okay, cool. But I want to do it with TypeScript. Also give me the setup of the project as I'm using Arch Linux. So it's defining a button in a constant. So the object, which kind of a class, it is an object what's been created. Then it defines the style. What kind of CSS definition is this? Ew, I don't like this. I guess I would prefer to use TypeScript. It's really messy in JavaScript actually. We have found a constant, more constant functions, and JSX returns. Wow, I don't know. Do I really want to learn reactjs? Components. How we fetch data from APIs. How we handle routing. I don't know, man. I don't know. Byte for better performance. We create tailwind CSS. Okay, let's see if it's much more friendly with React, with TypeScript. I hope it is. And I think we are done. Time's up. Yes, time's up. Let's take a look into portswigger.net. Interfaces, that's the thing. Interfaces to define the objects and properties. But that's just the properties. And then we define a React component. What's this? React.fc. We pass the properties, which is an interface. And we pass a comma separated attributes or parameters. And then we start defining the function. Oops. Inside we have some functions, no components, just functions. We have the return, which is the JSX, which seems to be the same as complex as it was in JavaScript. That's the component. We have another component here, submit form example. We use the use state. We manage the submit handler or event, and we return the HTML code. We create another component, which is the text input. So the text input is a component, right? Yes. We have registration form example component. We handle the change inside the form, we handle the submit, we verify, we make sure all the components of the form are in a good shape or are valid, and then we send the information. We submit the information. No, we don't submit, we just, what it does when handle submit. It just verifies the form is correct. And we trigger an alert saying registration successful, nothing else. We return HTML and that's it. Another example, we create cards component, product card example component, the model properties and the model component. It's using events on mouse clicks or touch clicks, confirmations. So it's a good example on how to create components and how good your skills are on CSS and HTML. So that's all about this. Not actually CSS, it's just calling some classes that should exist already. And I think those are coming from Tailwind. So how to say it? English. Tailwind. Say it.
With a huge tailwind from technology.
Tailwind. Tail.
At this
Tailwind.
event, in part because of agreements previously reached, the tailwind that you had going in.
Tailwind. Okay, clear. Clear, amazing. Okay, let's go with portswiggee. Let's talk a little bit on. Oh, what are you doing here? How you got here? And you even have an avatar. What a cool thing. Stock, the hacker that your friends told you about. Amazing. He's using Barb Suite a lot. Okay. Product Solutions Support Research Academy. Boost your career learning material. Build all labs, build all learning materials. Learning paths. Got a lot of things here. Dashboard. Sign up, login. Latest all content. Learning paths. I think I'm missing something here. Get started. Topic lists, all topics. So I have to go into all topics. I go latest topics, all topics, and I have it all. Server side, I guess, server side topics, authentication, SQL injection, path traversal, race condition, NoSQL injection, API testing, web cache, server side request forgery. Do we have IDORs? Wow, there is no IDORs. Is that client side maybe? No. Client side, cross-site scripting, cross-site request forgery, clickjacking, Doom-based vulnerabilities, advanced GraphQL API vulnerabilities, server-side template injection, authentication, JWT attacks, web cache poisoning, HTTP host header attacks, prototype pollution. Seems like a couple of things are missing here. It looks like. Look, let's take a look into the cross-site scripting, like from the beginning. So we'll not have particular examples here, we'll just have overall information. Pretty much conceptual. Conceptual. Portswiggee. Cross-site scripting. It's gonna be one of them. The first one, XXXSS. What we got here is nothing out of this world. Proof of concept, JavaScript injection, reflected, store, DOM base. The DOM base is the one I never heard of. Reflected, store, DOM based, DOM based. Store, I mean, which the reflected is going to be the one that can be seen by just opening the bad URL, which is poisoned already. The stored one is going to be a more serious one where you can just open up the URL or the web application and it can come already with the JavaScript injected in there. DOM based, DOM XSS. It has some client-side JavaScript that processes data from untrusted source in an unsafe way. So where you can modify the DOM, the application trusts the DOM, but you can actually modify it and do something evil. So okay, well, what that? How to find and test for XSS vulnerabilities? Barb Suite Web Vulnerability Scanner. Okay, Barb Suite has a vulnerability scanner. Cool. Manually testing, time's up. Document cookie. However, other types of DOMXs are harder to detect. To find DOM-based vulnerabilities in non-URL based input, such document cookie or non-HTML based things like set timeouts, there is no substitute for reviewing JavaScript code, which can be extremely time-consuming. Yeah, that's the way to go. Automated scanner sucks. Content security policy mitigates this kind of attacks. The CSP flag might hinder or prevent exploitation of the vulnerability. CSP can be circumvented to enable exploitation. Okay, CSFC can protect, prevent from XSS. Dangling markup injection, how to prevent, okay. How to prevent filter inputs on arrival, encode data and on outputs. Use appropriate response headers to prevent excesses in HTTP responses that aren't intended to contain any HTML or JavaScript. You can use the content type. Okay, content type CSP. Common questions. Next, there is no next. How does this work? Impacts. Proof of concept. Testing. View labs. So it's just labs. SQL injection. Cross-site scripting. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 practitioner. And we have a bunch of levels. What this one? Do I need my computer? Access the lab. Yeah, I need my computer. Okay, so it's gonna be pretty straightforward. We just need to learn to read. So that's it about cross-site scripting. Just one page of documentation. One page of documentation. Exploiting XXS vulnerability. How to steal the cookies. Now this is another page. Content security policy. What it is, how it works, the strict self protecting. So there's a bunch of things here. Reflected. What is this reflected? Oh, submit, random, test payload. Common questions about reflected cross-site scripting. I don't really want to ask the common. Stored. What is stored? Well, I need to store the payload in database somehow. How to find DOM XSS, yeah, content between HTML tags, yeah, properties, whatever, errors, events as well. HTML encoding is needed as well. Client-side template injection. Exploiting XSS vulnerabilities. Dangling markup injection. What actually is this? To capture data across domain in situations where full cross-site scripting attack is impossible. I don't get this. DOM exploiting content preventing cheat sheet. Oh, we got a cheat sheet. I don't think. Oh, we have like a database of cheat sheets. Amazing. I don't really like portswiggee. Why I'm looking into this? Okay, I read about cross-site scripting, but let's see what Claude can teach me about this.